Good evening, Year 11. This is your video for the night before your higher maths paper 3 tomorrow morning. So just compiled a list here of some topics. I just had a last minute look through the paper yesterday, and from first glance these are topics that I do not believe we have seen yet. It's not an exhaustive list, and obviously sometimes things do crop up again, but if you want to choose a topic from here to revise tonight, this is probably some of your best bets of things that could possibly come up in your paper tomorrow morning. Just like normal then, I've chosen a couple of topics to go through, and there'll be some similar questions for you to have a go at before you can mark those. So our first one I wanted to look at was further trig. We can see here we've got two triangles stuck together, and we should always be asking ourselves the same series of questions when it comes to triangles in our exams. First one being, is the question about area? This one clearly isn't. It hasn't told us an area, and it's not asking us to find one, so we do know then that we're not thinking about half AB sine C or base times height over 2. Second question, are they right angle triangles? No, they're not, so we can eliminate Pythagoras and SOHCAHTOA for the time being. And our next question is, do we have a matching pair? And we do have a matching pair in this second triangle on the right here with the 68 degrees and the 11 centimetres. So we're going to be able to use the sine rule to answer, or to find out some missing information, sorry. When we think about what would be a useful piece of information to work out, then we need to consider what we are working out. So we're trying to work out what that angle is. So if we can work out this missing length, then that's going to provide us with another piece of information in that triangle on the left that we can then use to solve for x. So we don't have a matching pair on the left, but once we've got that connecting length in yellow, then we will have enough information to use cosine rule. So let's start off just by looking at this triangle on the right hand side. I'm just going to sketch it out. 48 degrees, 68 degrees, 11 centimetres, so we've got our first matching pair there, and like we said earlier, we're looking for this measurement. I'm just going to label it Y for the time being. So if that's the side that we're looking to find, then what we do need to do is work out its matching pair angle, and because angles in a triangle add to 180, we can just take away the 68 and take away the 48 to find us that angle there. 64 degrees. So we know this is 64 degrees. When we do sine rule then, you can either choose to put your angles on the top of your fractions or your side lengths. And we're looking for a missing side, so we're going to choose the version where our side lengths are in the top and our angles are in the denominators. And then I'm just going to substitute in my missing information. So I've got y over sine of its matching pair angle, so 64, is equal to 11 over sine 68. And solving for y then, I just need to multiply 3 by that denominator. So y equals 11 over sine 68 times by sine 64. I'm just going to type that in my calculator then. And we get 10.66318666, and I'm not going to do any rounding at this moment. If we go back to our original diagram then, we do now know that this side length here is 10.66. I'm not going to write the whole thing out, it's still stored in my calculator. And if I draw out that triangle now down below, we've got this side here being the 10.66. Just scroll up to see those measurements. We've got a 15 centimetres and a 12 centimetres, and then we're looking for x. So not about area, no right angle, no matching pair, must be cosine rule. You will get given on your formula sheet the sine rule and the cosine rule, and we just need to substitute in. So when we're substituting it in, just be careful. We are looking to use this formula to find out our missing angle. So in our formula, that's going to be A in part of cos of A. So the matching pair side is lowercase a. So when we're substituting in, we need to make sure that we're using the 10.66 as A. So we're going to have 10.66 squared, and that's going to be equal to 15 squared plus 12 squared minus 2 lots of 15 times 12 times cos of x. If we're trying to find the angle, then we need to make cos of x our subject so that we can then use inverse cos. So the first thing I'm going to do is get rid of this 15 squared and this 12 squared by subtracting. So we'd have our 10.666 squared minus the 15 squared minus the 12 squared, and that's equal to negative 2, lots of 15, lots of 12, lots of cos of x. And now again, still remembering what our goal is, to try and get cos of x by itself. All of that is being just multiplied through by cos of x. So to get rid of it, we can just do a division. So 10.66 squared minus 15 squared minus 12 squared over the minus 2 lots of 15 lots of 12, and that's equal to cos of x. So now we've got that as a subject, we can use inverse cos to leave us with x. So we just need to do inverse cos to the left hand side as well. And our calculator is going to be able to do all of this for us. So I'm just going to type all of that in. I've still got the 10.66, the exact answer, stored in my calculator as the answer. So I'm going to do answer squared minus 15 squared minus 12 squared. That's all over negative 2 lots of 15 lots of 12. Closing all my brackets there, that's giving me the answer of 44.83364788. The question asked us to round that to one decimal place, so that's going to give us 44.8 degrees. Okay, here's a really similar question for you. If you just pause the video, have a go, unpause when you're ready to see the answer. Okay, here's the answer there. So you're going to get your first mark for setting up your sine rule for your triangle on the right hand side. Make sure obviously that you are using the matching pair angle for the side you're trying to calculate, so the 56 degrees. You get an accuracy mark for getting that correct, and then a method mark for substituting all of your values into the cosine rule. You would get what we call a follow through mark here, so if you had calculated the wrong length for your first part, if you'd substituted that incorrectly, you would still get that method mark. You get a method mark for rearranging it to try and make cos of x your subject, and then an accuracy mark at the end for your final answer. Capture, recapture is the second one I'm just going to go through here. So if we read the question, we're going to try and form ourselves some fractions that represent the proportion of marked fish in this pond. So if we just look at this first little paragraph here, it says on Thursday she catches 180 fish. They are marked and then returned to the pond. So of that 180 fish that she captured, all of them were marked, and that's out of the total fish in the pond, which we don't know. So we're just going to call it x, n, any letter would be fine. Our second proportion then comes from this second little paragraph. So catches 305 fish, 45 are marked. So the fraction of those fish that are marked is 45 over 305. We're going to set those proportions equal to each other because we're going to assume they are equal for our estimate, and then we're going to solve for x. As they're both fractions, one of the easiest ways to solve this is just to take the reciprocal of both sides. So we'd get x over 180 equals 305 over 45, and now we can solve for x just by multiplying through by our denominator. So x equals 305 over 45 times 180, which gives us 1,220. So that's going to be our estimate for the number of fish in the pond. There's quite often a follow-up question here. It could be about what have you assumed, or what assumptions have you made? So you could say, none of the fish, no new fish entered the population, no fish left the population, none of the marks rubbed off, or the tags fell off, or depending on the context. In this case, it would be marks rubbing off. So this follow-up question isn't an assumptions question. It's asking you what would happen if something was different. So it's saying, okay, we assume that none of the marks had rubbed off, but if that is wrong, what effect would that have on your answer to part A? So we can literally think about this as an example. If some of those marks had rubbed off, then that means that our second fraction, representing the marked fish in that proportion, may well be incorrect. So we had 45 fish. We had 45 fish with a mark on, but if some of those rubbed off, originally there could have been a higher proportion here. So let's say there was 46 out of 305 marked instead. Well, when we solved for x, we would flip that over and then times it by 180. Your denominator now is larger than it originally was, which means this fraction is going to give you a smaller value itself, and then it's being times by 180. And so that's going to give you a smaller answer. If you times a smaller number by 180, you should expect a smaller answer. And that is not a nice number, but it makes the point that this is going to give us a smaller answer. So the effect that that's having our answer to part A is that it would be an overestimate. Okay, another way you could phrase that is, it would decrease my estimate if we knew that some of those were had rubbed off. Okay, so here's a really similar one. I hope you can see both parts of the question there. Pause the video, have a go, unpause, be ready for the answer. Here are the answers then. So for the first question, we should have got 450. Not sure what that mess is about there. The first mark is for setting up those two proportions. The second mark is for your process of solving it. And then your final mark is for the answer of 450. And then the assumption being wrong was actually really similar to that first one we looked at. So this again would be an overestimate, and we can think about that by looking at those two highlighted parts here. If that 8 actually should have been maybe 9, then when we do our solving, we would get a smaller answer than 450. The final one I wanted to go through today was quadratic inequalities. So here we've got a rectangle. It says the area of the rectangle is less than 17 centimetres. So what do we know about how to find the area of a rectangle? Well, we would multiply the two side lengths together, the base and the perpendicular height. So we'd still do that even though they're algebraic. So I'm going to do 2x minus 5 times x plus 5, and we know that that's going to represent our area algebraically. We've also been told that that's less than 17, so we can say that that algebraic representation of our area is less than 17 as this sort of mathematical statement of inequality, and we can now expand that, and hopefully we end up with this statement here that we're trying to show. So if I expand this bracket, we can use the grid method. If you use the grid method, we would end up with 2x squared, we have a plus 10x and a minus 5x. That's going to give us plus 5x. A minus 5 times by 5 is negative 25, and that's still less than 17. The 2x squared matches exactly what we've got here, and so does the plus 5x, but we've got a 0 and a minus 42. So we can just subtract our 17 to make sure that we have a 0 on the right-hand side, and in doing so, we've got negative 25 take away another 17, and that does give us negative 42. So we've shown that that is the case, that is true. In part B, it wants us to find the range of possible values of x. So we're going to have to solve this quadratic inequality. I'm going to start off just by setting it equal to 0. I know it's an inequality, so therefore it's not equal to 0, but what I'm looking for is what we call our critical values, so we can determine those critical values for x, and what x therefore would need to be greater than or less than. We do obviously have a quadratic here where our coefficient is greater than 1, so we've got our little method we can use to factorise that. Obviously it's a calculator paper, so if it doesn't factorise easily, you can always just use the quadratic formula. So I'm looking for numbers that multiply to make negative 84. So I'm just going to consider my factors of 84, and I know they'd have to have different signs, and therefore a difference of 5. There's quite a few factors of 84, so you could be sitting and thinking about them for a long time. So I'd suggest just listing them, because there's only a finite number. If you list all of them, then you're definitely going to have the correct pair in there somewhere, and it's just looking for it. So I've got 1 and 84, 2 and 42, 3 does go in because 8 plus 4 is 12, so that's our test of divisibility for 3. And again, you've obviously got your calculator, so you could just be trying out the factors and doing 84 divided by 3. But what we should find is that gives us 28. 4 definitely goes in as well, to be 4 times by 21. 5 won't go in. 6 will go in. It will be 6 times 14. And it will be 7 times by 12. And actually, that's going to be our factor pair, isn't it? If we have a plus 12 and a minus 7, that's going to give us our plus 5x in the middle. So we can rewrite now our quadratic equation, and we can separate that 5x into a plus 12x and a minus 5x. We've still got our minus 42 at the end. Cut that in half and factorise both sides. Factorise the side on the left first. That tells you what your bracket needs to be because they have to be the same. And then you can just think about, oh sorry, that should be a 7 there, shouldn't it? 12 minus 7 is what equals the 5. This second bracket has to be the same, so that kind of helps you factorise on the second side. And we can see we need to multiply through by negative 7 to give us a negative 7x and a negative 42. So our factorised form then is our repeated bracket and the 2 factors from our factorising, and that is equal to 0. We can get our solutions from there, or our critical values, sorry, not our solutions in this case, by setting those equal to 0. So x equals 7 over 2, or 3.5, or x equals negative 6. So with a quadratic inequality, the way that you now need to check what your sign should be is you should draw a sketch. We know it's a positive quadratic, so we're expecting this U-shaped parabola, and we now know where it crosses the x-axis. These are our critical values here. So we're going to have 1 over at negative 6, and 1 at 7 over 2, and we've got our U shape coming through like that. We need to think about what part of the graph we're looking at. So because it says that it has to be less than 0, then we're looking below the x-axis, and we're going to consider values on that part of the graph. If we go up and we try to read where they would be on our x-axis, you should notice that they're always going to be between the negative 6 and the 7 over 2, which gives us negative 6 is less than x is less than 7 over 2. X has got to be between those two values. But because we are now in a geometric context, we are going to have to just check whether or not all of those values are valid. In particular, we're going to be considering this negative value. I don't see any reason why it couldn't be 7 over 2, values less than 7 over 2. But if we go up and have a look at our dimensions, if x was negative 6, does that make any of those side lengths negative? Because we can't have a negative measurement. And the way we can think about that is by just checking what the values would need to be here and what the values would need to be here. We know that they would have to be greater than 0. So if 2x minus 5 is greater than 0, we can add the 5 on and divide by 2, and that says x has got to be greater than 5 over 2. So negative 6 is definitely too small. And then here, x plus 5 has also got to be greater than 0, so therefore x has got to be greater than minus 5. So this is our more restrictive one, because we do know that x has to be the same, and we need x to be bigger than 5 over 2, otherwise we'd get a negative length. So that's going to have to be our lower bound on our quadratic inequality, and we're going to still have our upper bound of 7 over 2. Okay, so here is an incredibly similar question. So you've got part A and part B. So show that, and then in part B, you need to do your solving. Pause it now, have a go, and then unpause when you're ready to see the answer. Okay, here's your answer then. Just going to ignore the top bit for now because that comes in part B. In part A then, you're going to get your method mark for setting up your equation, your inequality, and accuracy mark for finishing the proof. And in part B, your first method mark comes from correctly factorising, so you've got your method that you can use to do that. And then you're going to get an accuracy mark for getting your 2 critical values. You're going to get a method mark for identifying the correct inequality from the graph, but you do not get your final mark until you've just checked whether or not we need to adapt our lower bound. And we do. You can see in our answer here, that was negative 8. We've gone for negative 3, and that comes from up here, looking at your 2 answers to see which one we need to make sure we're bigger than. And to make sure both of those aren't negative, we need to be bigger than negative 3. So that's why our lower bound here is negative 3, and our upper bound is still our 3 over 2. Okay, so that's it. What can you do now if you want us to keep revising? Well, you've got some great resources here listed on the screen. You can look up any topics on there. If you want full papers, take yourself to Maths Genie. I'll get yourself onto Revision Maths. Exam Q is great. Just make sure you're selected higher. I think that's default when you go onto the website. You've got Corbett Maths, you've got Hegarty Maths, and good luck.